In this unit, we are going to be learning about quadratics. But before we can talk much about quadratics, I want to talk a little bit about the family that quadratics belong to. And that family is called the polynomial family. Polynomial. And so what is a polynomial? Well, we've seen polynomials before when we were studying linear functions and linear expressions. We were studying polynomials. We may not have known it at the time, but those were polynomials. So here's a linear expression, 3x subtract 4. That's a linear expression. We could make it a linear function if we just said y equals 3x subtract 4. And in this unit, like I said, we are going to be learning about quadratics. And an example of a quadratic would be, let's say, 2x squared plus 7x subtract 3. That would be an example of a quadratic expression. And again, both of these are polynomials. So what makes them polynomials? What makes these expressions polynomial expressions? Well, there's a few requirements. So let's see here. I'll write out requirements. These are the requirements or things that have to be the case with an expression in order for it to be a polynomial. So the first thing is that we need to have a finite number of terms. Finite number of terms. And a term, remember, is just the parts that are separated by addition or subtraction. So this is a term, this is a term, this is a term. So we need to have a finite number of terms. So this has 2 terms, the linear expression here, and then this quadratic expression has 3 terms. So we need to have a finite number of terms. The next thing that we need is our expression or our function needs to be made up of constants, variables, and or exponents. So that's the next thing that we need to have for this to be a polynomial. The third requirement is that those exponents must be natural numbers. They must be natural numbers. You may remember the natural numbers are, and for our purposes here, there's 0, 1, 2, 3, and so on. So we cannot have negative exponents. We cannot have fractional exponents. They must be either 0, 1, 2, 3, and on up from there. And then finally, for an expression to be a polynomial, we must have no division by variables. No division by variables. So for example, division by a variable would be like a term that was 2 divided by x. We cannot have that because that would be division by a variable. So none of that. So these are the requirements for something to be a polynomial. And we'll get back to those requirements in just a minute, but before we do, I want to write out another example of a polynomial and then talk about some of the definitions or terminology of the parts of the polynomial. So the polynomial that I'm going to write is negative 3x squared plus 1/2 x subtract 6. And the first thing that I want to talk about, or I just want to review the terms. So we talked about the terms over here, underlined in yellow. So this is a term, this is a term, and this is a term. So there are 3 terms here. 3 terms. And there are special names for 2 of the terms in our polynomial. Here on the end, this is our constant term. This is our constant term. And You may have guessed the reason that it's the constant term is because it doesn't change based on the variable changing, because we're not multiplying it by a variable. And then the other term that has a special name is this term here, this term that has the largest exponent on it. So this is x squared, that's the largest exponent of all the terms. That is our leading term. Leading term. And then the numbers that are in front of the variables, those are called our coefficients. And I'll underline those in teal here. So this, the first term here has a coefficient of -3, and then this has a coefficient of 1/2, and then our constant term, that's a coefficient of -6, and our leading coefficient is attached to our leading term. So this is our leading coefficient. Leading coefficient. So our leading coefficient is -3. Another thing that's important to know about a polynomial is the degree of the polynomial. And we find the degree by just looking at what the largest exponent attached to a variable is. And so this has an exponent of 2, this has an implied exponent of 1, this has an implied exponent of 0 with our constant term here. And so the degree of this polynomial would be 2, because 2 is the largest of all those numbers. So this has a degree of 2, and we know that because of that 2 right there. And then some other descriptors, a couple other descriptors that we can use to describe this polynomial is that it's a trinomial because it's made up of 3 terms. So it's a trinomial. Oops. Trinomial. And we say that this polynomial is in standard form. It's in standard form. And standard form just means that the degree of our variables here goes down as we go from left to right. So this variable right here has degree 2. This variable has degree 1. There's no variable here. This is our constant term. And so they go down from 2 to 1 and then essentially 0 here. And so it's in standard form because the exponents are going down in size, or the degree on those variables is going down in size. So the entire polynomial is a polynomial of degree 2, but we can also talk about the degree of the individual variables also. So again, this is a trinomial because it has 3 terms, and it's in standard form because the degree of those variables goes down as we go from left to right. Now let's play a little game. This game is called Polynomial or No. It's one of my favorite game shows. You can find it late at night on, I'm not sure what channel it's on. The math channel, I guess. Polynomial or No. And let's play. I'm going to write down some polynomials here, and as I write them down, I want you to think, is this a polynomial or not? So number 1 here is 2x subtract 3 plus 4x cubed. Is that a polynomial? Think about it. Number 2, 12x plus 4 over x subtract 100. Is that a polynomial? Number 3, 7x to the 4th power subtract x to the 1/2 power plus 3. And then finally, number 4, the million-dollar question, x plus 2. Is that a polynomial? Okay, let's go through these. So 2x subtract 3 plus 4x cubed. Let's look at these. Do we have a finite number of terms? Yes, we have a finite number of terms. There are 3. Is it made up of constants, variables, and or exponents? Yeah, we have a constant term. Up here we have a constant term here. We have variables and we have exponents, nothing else. So it meets the second condition. Are the exponents natural numbers? The exponents natural numbers. Looks like we have an implied exponent of 1 here. and let's see, and 3. So those are both the natural numbers, so it meets the third condition. And is there any division by variables? No, there's not. So yes, this is a polynomial. Let's get a nice yellow color here. Yes. Oops. Yes, this is a polynomial. Okay, number 2. Let's see. 12x plus 4 divided by x subtract 100. We have a finite number of terms, 3 terms. It's made up of constants, variables, and or exponents. Okay. Exponents are natural numbers. Yeah, we have this is implied exponent of 1 and 1 there. So that works. And then no division by variables. Uh-oh, look at this. We have division by a variable. So this is not a polynomial. Okay, number 3, 7x to the 4th, subtract x to the 1/2 power plus 3. So we have a finite number of terms, 3 terms. It's made up of constants, variables, and exponents. Yep, I see there's a constant term, we have variables, we have exponents. Let's see, exponents must be natural numbers. Okay, there's an exponent of 4, there's an exponent of 1/2. But 1/2 is not a natural number. So this is not a polynomial. And then finally we have x plus 2. Could have written that 2 a little bit better. X plus 2. Now, is x plus 2 a polynomial? We have a finite number of terms. We have 2 terms. Is it made up of constants, variables, and or exponents? Yeah, we have a constant term and a variable. Let's see, exponents must be natural numbers. This is an implied exponent of 1 there. So that checks out. And then no division by variables. Okay, there's no division by variables. So this looks pretty different from the other polynomial, or from this polynomial, I should say. But yes, this is still a polynomial. Yes, this is still a polynomial. So we are going to be talking about quadratics in this unit. We're going to be focusing on this part in blue, but it's important to remember the family that this is a part of. It's part of the polynomial family.